Hey everyone, Jordan here from the Protocase team. Today we're going to cover threaded features in CNC machine parts. Here at Protocase, we're your one-stop shop for custom manufacturing. We help you keep your projects on track by making your fully finished custom CNC machined and sheet metal parts in as fast as 2 to 3 days. And we never enforce a minimum order requirement. We've covered many different CNC machining topics in our Proto Tech Tip series, including helical inserts, corner radius, and CNC features. Check out the links to those videos below. Today, we're going to focus on one CNC feature type in particular, threaded features. As mentioned in our tech tip on CNC machine features, threaded features are very common in CNC machine parts, as they're used to fasten components within a larger assembly together. What type of threaded feature your part requires will entirely depend on your design, but let's get into the details of what we can make for you. Before we get into it, let's go over the basic threaded feature types, as they'll be referenced throughout the video. Threaded features can be categorized into two main types, external or OD threads and internal or ID threads. Internal threads can be further categorized as open or through, or as closed or blind. In addition, at Protocase, we offer internal threaded features with inserts, stocking a wide range of both metric and standard sizes of helical inserts we will install for you in-house. Typically, helical inserts or other threaded inserts are added to designs where extra strength or increased wear resistance are required. For example, an aluminum part may have a stainless steel helical insert installed to provide a more mechanically strong threaded feature. It also prevents degradation of the thread if a fastener is going to be installed or uninstalled many times during the lifetime of the part. For more information on threaded helical inserts, check out the video linked in the description. Threaded features can be created on both our lathes and our mills. On a mill, they are manufactured using one of two types of tools, a tap or a thread mill. On a lathe, taps and threading inserts are used instead. What tool type and size is used is going to determine the constraints placed on your threaded feature design. First, let's talk about thread mills. For simplicity, we'll focus on single flute thread mills. We use them most commonly due to their flexibility, since Protocase is a shop for prototyping and development. Thread mills work by traveling in a helix around a hole or a post, cutting material away to form the thread shape and size specified. They are most commonly used for manufacturing large internal threaded features or external threads. There are a few main constraints to keep in mind for thread mills. First, if an internal thread is being cut, the thread mill must be small enough to fit within the minor diameter of the thread. Second, the thread cutting tooth on the tool must be the proper size for the thread height or pitch required. Third, there must be enough clearance on the far end of the feature to allow the tool to fully thread the depth required while not colliding with the part. Typically, this would come in the form of a shoulder on an external feature or extra bore depth for an internal blind feature. Finally, the reach or length of the thread mill must be sufficient to reach the full depth of the threaded feature. Threads created using a threaded insert tool on a lathe have pretty much the same limitations as a single flute thread mill, at least as far as affecting your design goes. Both thread mills and threaded insert tools are handy because we can use them to make many non-standard thread sizes. Just point out these in your design documents and our engineering team will review them for manufacturability. Taps are used in both our lathes and our mills to create the most common size internal threaded features that are about less than an inch in diameter. There are a number of subcategories of taps, but the two broadest categories are cut taps and roll form taps. We use roll form taps in aluminum, for example. They force or roll material around rather than cutting the material away, resulting in a stronger thread. Conversely, we use mostly cut taps in plastic, as deforming the plastic to create the thread creates inconsistent sizes due to the plastic's material properties. Regardless of the type of tap that's being used, we're always constrained on blind or closed holes by the lead on the tap. The lead on the tap can be thought of as the portion of the tap that can't thread the hole. Therefore, in order to thread a hole to the depth of, say, 1/4 inch, a blind hole feature must have at least 1/4 inch depth plus the depth required for the lead. Typically, the lead on a tap ranges in length from 1.5 times the pitch to 2.5 times the pitch. So, we usually add at least that to the depth of the bore, plus about 10,000 safety factor. Taps are also constrained by the reach of the tap, or the tap's tool length. It's important to note that regardless of how we're going to manufacture your threaded feature, in order to do so, we need to know that the threaded feature is required. Sometimes threaded features can get missed at our quoting stage when only a 3D CAD file is provided. I would always suggest providing a drawing file with your threaded features specifically noted whenever a threaded feature is required in your design. This concludes our tech tip on CNC threaded features. We stock a wide range of both imperial and metric taps and helical inserts, as well as pipe taps. We can also thread custom-sized features using thread mills or threaded insert tools. If you have a design that you would like quoted, contact us by emailing info@protocase.com or using our request a quote form on our website. Thank you for watching this week's Proto Tech Tip. We'll see you back here next week.